This is a quick video to tell you how to do a 12 volt battery, or how to make batteries out of old reused 18650 batteries. Ingredients, tools needed, supplier batteries of whichever you prefer. I'm going to be using 18650s. You need like a lattice that you can put the batteries together with. You need a battery tester. You need insulation tape, captan tape. You'll need a spot welder. You'll need some of these stripping for the spot welder. You need a BMS for whatever voltage you need. I'm going to be using an empty bottle, plastic bottle. Need a multimeter, soldering iron with solder and flux, and somewhere to remember things. In my case, pen and paper. The very first thing we need to do is to sort out our cells into their physical sizes. Some of these are bigger than 18650, some of them are 18650, and some of them are like a really small version of an 18650, which is more like a 16650. So we'll sort them out into their sizes. And there they are sorted out into the smaller 18650s or the 16650s, the 21650s and the 18650s. These are the ones I'm going to be using. Now, because these were salvaged from my local recycling centre, there's no guarantees as to how good they are, if they've got good capacity or anything like that. So first off, we need to test them to know. So this is where this comes into play. What we'll do is we'll be putting the batteries through this one by one to check them. Bear in mind, it's a lengthy process. It can take up to a day to do one cell if it's a high capacity cell. This one will discharge them up to the maximum 4.2 volts. Then it will discharge them down to 3 volts, either at half an amp or 1 amp. Sorry, make that at 1 amp or 2 amps. So first off, we need to sort that out. So now we've got the machine set up and ready to go. Get our cell. Now these got 2 slots in them. One is to power the device, but you can also power it from USB cable, which is what I'm doing. This is the slot that gets used for discharge and testing. So what we'll do is we'll put our cell in there. I always prefer to switch it off before I do anything. And now we've got these options here where we can go on charge mode only, discharge only, or automatic. Auto is where it will charge it up fully, then it will discharge it, measure it, and then it will charge it up fully again. Here is where I adjust the power, and you'll see the F change to a H. That's half power, which will use 1 resistor. And this is now full power, which will use both resistors. That's how it manages to go from roughly 1 amp to 2 amps. So now I'm going to be on automatic, and then I'm going to press start. Right, so now we're charging at half an amp. And we just let it do its thing to charge it up, discharge it, charge it up, and then it will tell us what the total capacity is. This machine also tells me the internal voltage, internal resistance, which is 100 milliohms. So we'll just let this continue. Once you've finished testing all the cells, what I do is I tend to put a bit of masking tape on there just temporarily. I'll give the cell a number, i.e. this is number 242 out of 300 I checked. It's got 711 milliampere hours and 113 milliohms. What I'm going to be using these for is a really low current output, so it's not going to be drawing a lot of power. Hence I'm happy to use these quite low value 18650s for this project, just to show you. So we've got our number, our milliamps and our milliohms. So what we need to do is do that with every cell, which I have done. I now have all my cells in order with capacity, with the highest at the top of the pile, going all the way down to my lowest. My lowest being 766 milliampere hours, my highest being 1428. Next we need to sort out the lattice to hold as many of these as possible. I'm going to be doing it by 4S, so I've got divisions of 4. Next up is to sort out these into equals pairs. These are spare, don't need them. I'm going to keep them as they are. So now we have 4, 8, 16, 20 cells that I can hold. 20 cells I'm going to be doing a 3S. So 20 divided by 3 isn't a round number, so if we go down to 18, 18 is divisible by 3, 6 times. So we need the 18 strongest cells. And there we are. There's my 18 strongest cells. Now the reason I've chosen 18, if you remember, they're going to be cells in 3 in series. So we're going to have to work it out to multiples of 3 cells. Hence, I've chosen 18 because I can then have 1, 2, 3, 4, 5, 6 lots of 3. So this will then be a 6 3S, 6 parallel, 3 in series. So now we need to sort out the 3 piles. And when sorting out the 3 piles, we need each of the 3 piles to be pretty much the same capacity. So the way I do this, I take one from the top, one from the top, one from the top. I take one from the bottom, one from the bottom, one from the bottom. And again, one from the top, one from the top, one from the top, one from the bottom, one from the bottom, one from the bottom. And I find by doing that, you're generally going to be keeping the 3 piles pretty equal anyway. One from the top, one from the top, one from the top, one from the bottom, one from the bottom, one from the bottom. So they should be relatively close. So I've written all the batteries down into their relevant banks. We've got bank 1, bank 2 and bank 3. These are all the cells in bank 1. These are all the cells in bank 2. These are all the cells in bank 3. Now we've added them up. Bank 1 is now 6,951 milliampere hours. Bank 2 is 5,383 and bank 3 is 6,738 milliampere hours. We need to try and get them closer, so I'll take a high level because this needs to be lifted. I'll take a low level from here and replace it with a higher level from the highest number. So I've juggled some cells around by taking some from here and swapping them around with bank 1 and bank 2. So I've now got them to 6674, 6802 and 6738. So they're all within 150 milliamps of each other, but what I'm going to try and do is raise that one a little bit, lower this one a little bit, see if I can bring this down closer to 680 and that one up a little bit to 680 odd. So just messing now with these two just banks. To reiterate, this one needs to come down 100-ish to 68 and this one needs to go from 6600 up to 68. So we're looking for a difference of about 100, which means 50 up or 50 down from here, 50 up from here. So I've taken a 1000 from pile 3 and I've taken a 1050 from pile 1. Now we'll add them together and see if they... So I've done a bit of shuffling. I've shuffled some from that pack into that one into that one, that one into that one, and vice versa. Because whenever one is higher than the other, if it turns out that this was 100 higher than that, what I'll do is I'll choose something from here and there, which is 50 difference. So then I'll take like 1250 from there and swap it for 1200 from there. So that will go down 50. That'll go up 50, but then when you add that 50, so that'll go down 100, that'll go up 100. And then they'll balance. And I've swapped and changed that until now I've got 6718 on the first, 6750 on the second, and 6754 on the third. So I've basically got 36 milliamps difference between the highest and the lowest. That suits me fine. The next thing I like to do with my 3 packs is to recover them in different colours. So each pack has its own colour. Then it don't matter if I drop them, get them mixed up. They'll still be in the same bags. So we've taken off all the covers from them batteries. Now to put these shrink wraps on. So now each of them from bank 3 is in their own colour shrink wrap. Before we heat seal these shrink wraps up, we need to put some insulators on the top, because the centre of this is positive and this ring around the outside is negative. It'll be so easy to short out when you're soldering. So what we need to do before we put the shrink wrap on is stick some insulators on the top. Just like once you've got the ring stuck on, the insulator, put them so they're in the shrink wrap, an equal amount. So now we've got our 3 packs of 6 in their own different colours, and they've all been given an insulator top, and they've all been placed in the centre of the shrink wraps. A lot of people use heat guns with these, or naked flames or blowtorch. I find it can be a bit aggressive. I just use a 1 kilowatt heater that I can rotate on its back. Air can get in from behind. These are all central and I just sticks it on there. Rolls it around. And when they're done, they look like this. And so on. We've done our capacity checks, we've put them into banks of 3 and we've coloured them for the individual respective banks. So 3 lots of 6. Each one has the insulator and the shrink wrap fold over the edge, so the edge is insulated, bottom is free on each one. On the likes of this one, I'll put an extra insulator because the shrink wrap didn't quite cover it. Didn't ensure the battery was centered. So I will cover up the ones that the shrink wrap isn't fully covering. So now that we've got all the batteries into groups, there's 18 in total, but my grid is 20. So I'm going to use 1 false cell. And where there's going to be a gap is where the BMS will go. So the way we do this is all the same colours will go the same way. So these are all positive down. The next lot will be positive up. The next lot will be positive down. We'll do it like this. Come on. positive going to negative, be bridged, and the same on the other side. Let's put the lid on. Put the false battery in. Now, we simply put the lid on. So what we've got now is the start of a battery pack. Now, we need to work things out. So, I'm going to put this in there. So, this is going to be the main positive, which means all these negatives will be connected to these positives, and positives will be connected to the negatives. Next up is to use the spot welder to weld plates across. So what we're going to be doing is joining this positive to these negatives. We're going to be joining this pack as one and this pack as one. So then this pack of 6 here and here, this 6 will work as one cell, these will work as another cell. Get these stuck on with the spot welder. We've now put all our cells in packs and soldered them as such. All these 6 packs you can see are joined together as one, then 6 are joined together as one, then 6 are joined together as one, and the same on the other side, then 6 are joined together as one, then 6 are all joined together, and then 6 are all joined together. And then what we've done is we've joined these two, so we have positive connected to negative, and positive. On the other side, we've got the negative connected to positive, and the negative. So what we've basically done is, we've got our 3 lots of batteries, right, so we've got our 6 batteries, so there it is, our 6 batteries. And what we've done is we've joined all the tops, the positives together, and now we've joined all the negatives together. So each of these is 4 volts, and because they're joined in parallel, we now have 6 batteries acting as one. So this, positive up there, negative up there. Next, what we've done is we've got our 6 batteries then as 1 battery. So these 6 are now acting as one. And then we've got the next 6 and the next 6. So in theory we now got 3 cells, i.e. blue, yellow and purple. So we've got our blue set, our yellow set and our purple set. Now the blue set, the negative, is attached to the yellow positive. But we've put the yellows upside down. So blue connects to yellow, which is positive. That's positive, and that would be positive. Then we have the yellow negative connected to the purple positive. So the yellow negative connected to the purple positive. And then down here we have a negative. So what we've got in cell 1 is 4 volt. Cell 2 we have 4 volt. And cell 3 we have 4 volts. So when this 4 volts is connected to that one, that positive to that negative, should be 8 volts. And then once we've connected this one to there, and then we've got a negative, the distance between here and here should be 8 volts. And them two. But then the distance between this one to this one should be 12 volts, because we have 4, 8, 12. Let's check that out. So here's our 6 blues. So if we just stick this in there somehow, one way or another. Right. So that is 4 volts, which goes down on the bottom of the blue, connects to the yellow. So positive goes down, connects to the yellow. So up here we should have 8 volts. And then at the bottom of this pack we should have 12 volts. And the bottom of the blues will only give us 4. So now we have our 12 volt supply. So now we've got to put the battery management system on. What I've done now is I've soldered tags onto this set, a tag onto that set. This is so I can solder wires to. I've got a tag on this set, and then a tag that connects this set. So we've got the 4 tags which we need to go on to there. First things first, I'm going to apply flux to here, like that, and the same to that one. So I've got flux added to them. Now I'm going to use a soldering iron to put a blob of solder on these 2 tabs. So now I have solder on these tabs, this one and this one. So now I turn it over and I'm going to apply solder to this tab and this tab. I'm going to have to extend that one first. Right, so the BMS has now been soldered on. I'm now going to put it in its place. Now the BMS has been put into place. The blank battery is in place and we have it all ready to go. Now, to support it all, by support it all, I mean wrap it up in something to protect it. And that's what the plastic bottle is for. Now we get back to the heater. Do this. A bit hot now, so be careful. Don't let it get too hot because it's not good for the cells. The bottle acts like shrink wrap. And there we have it. That's a hard plastic. Once that bottle's gone like that, how hard it is. And we have a battery. And indeed, we can't say it's a battery until we've done battery stuff. I hate vehicles. Black should not be live. Here we are. 112 volt lamp working. Job's a good one.